Sarah Lim's Fall 2015 quarterly sprint recap video. I worked with Nicole and Michael in the RALE layout project of the RALE SIG, and a lot of our work was picking up both from where PWAP had left off with regard to helping aspiring front-end web developers learn professional examples, as well as expanding on Josh's work with Unravel, which had to do with figuring out how to reverse engineer certain effects that occurred in a particular web page. So we had a couple of motivations when we approached this project. Initially, it was pretty open-ended. We didn't really know what direction we were going in, but from very cursory initial need finding and from our previous work, we did know that the internet has a slew of potential learning opportunities for aspiring front-end web developers who are particularly interested in not just learning basic HTML and CSS skills, but specifically adopting professional techniques. So nowadays, there's a proliferation of JavaScript libraries such as AngularJS and React that are used to dynamically generate content and websites and incorporate layouts. And these frameworks affect the page layout in a number of ways. First, as the Elevate website demonstrates, you can use Angular to stitch together a page using HTML partials in a way that's not immediately obvious to a learner who may not have previously encountered this method of including components or templating. So there will be subcomponents such as, in this case, an award banner, a nav bar, a footer, etc., stored in modular HTML files, and they'll populate container elements with content on the fly. Other examples, when you actually inspect this page, you can see in this scrolling banner that all of these instances of ng repeat are referencing some data file or a database to determine what particular content to include and automatically generating one such element, one of these icon elements for every object stored in this icon's collection of data. But none of these things are immediately obvious to learners who may be familiar with basic HTML and CSS, but not these new JavaScript content generation libraries. And that remains a fairly significant impediment to being able to learn professional web design techniques, as well as use professional websites as helpful resources, because these libraries, among other things, obfuscate HTML markup with, for instance, all these ng prefixed attributes that might be unfamiliar to learners. And there are a bunch of divs in this page that serve no purpose other than to be function as an injection container for other content that Angular puts in, renders when the page loads dynamically. So thus far, our work was pretty much motivated by the desire to help learners more effectively learn from research. More effectively learn from professional examples. Our need finding results revealed a bunch of things. First is that there were unclear connections between markup and outcomes. So, for example, here, a learner who is unfamiliar with these pages might not understand why saying ng repeat results in a series of icons appearing. The bricolage paper that we based a lot of our preliminary research and thought process on does in fact allude to this difficulty. Specifically, dynamically generated components can obscure the connection between the markup and the output because it abstracts away the declarative logic responsible for saying, here is a div that has the precision icon, and here's why it's on the page, etc. And learners would discuss frequently that they would have to use deep traces down into the DOM in order to figure out what precisely was responsible for driving a particular element's appearance. A lot of our need finding revealed two main problems. First is that there was an unclear connection between these things, and second is that in the iteration feedback loop, for learners who were trying to reconstruct pages based on examples, they didn't understand how to replicate the effects they saw on these example pages because dynamically generated components added a bunch of overhead in the form of alternate debugging environments and additional layers of complexity. One quote that was basically a good summary of what all of our participants said was, even if you do make some of the markup on a more professional site easier to read, it's much more difficult to check your work and make sure you're doing things correctly. When you run into issues with child styles and having to go 3 levels down just to find the container responsible for that information, it gets frustrating. There isn't really an easier way to sort through the DOM to find what you need other than to inspect each element and try to find the top level and work down from there. So from our need finding, we generalized to 3 research questions. First is, when learners select professional examples, what factors influence their choices? Second was, how can we make professional examples more accessible to intermediate learners, i.e., how can we make all of this code make more sense to someone who is familiar with basic HTML, CSS, and JavaScript, but not any of these proprietary directives? And lastly, how can we expose the structure of the DOM in relation to content generation frameworks such as AngularJS and React? So our system is pretty simple. It runs as a bookmarklet, as it is. And when you click on it, it highlights all of the dynamically generated elements in the page so that users can more easily create a visual relationship between directive markup and the result as produced by the framework. And the way we do this is first by checking for framework usage by querying the global window for JavaScript variables such as the Angular variable, the React variable. In this case, this website uses Angular, so if we use the console, you can see by loading all the objects in window that the Angular object is in fact accessible on the global level. So once we check for these particular variables, we can then parse the DOM for injected nodes using HTML pattern matching for particular patterns that are indicative of particular frameworks. So for example, for Angular, we would search for elements with attributes prefixed by the ng- directive. For our page that used React, we might search for the React-data ID directive because that's specific to React applications. And then we inject a CSS class to give each element a outline in a semi-transparent overlay, and then apply the overlay class to any node that our pattern matching flags as having been dynamically inserted. This allows the learner to visually distinguish injected content from the static content on the page. From our initial user studies, we have gotten a few important observations. First is that this visual aspect is helpful for learners in determining what content they should design through dynamic generation frameworks and what content they should implement statically. So for example, on this page, things like individual section headers are all statically implemented into the page, whereas any scrolling or dynamic content here is done through Angular generation on the fly. Um, Additionally, when you view the source of the page, because of the use of partials, it's not immediately obvious what is responsible for what thing. And then when you try to inspect the elements, it's easy to get overwhelmed by all of the markup. And using this tool, we can see what exactly is responsible for the additions in markup between the pre and post rendered DOM. It also works on websites where learners might want to understand why particular elements have been implemented the way they are. So if I wanted to build a very similar layout to this, maybe not with, Subaru models, but for multiple cards for different things that compared features, this provides a good design pattern for me to understand ways in which I can use Angular to show a variety of cards, each depicting, oops, each depicting a model in a collection called Selected Year. And lastly, for the sort of canonical example of an Angular-powered app on a to-do list, you can see here that things like what needs to be done is a UI element that can be implemented in a static fashion, but each individual to-do is generated on the fly, which can help a user which provides a visual affordance to help the learners reverse engineer programs. And this was also a feature that our learners liked through initial testing. Another thing that worked successfully was the form factor of this extension. We wrestled for a while with the Chrome extension architecture, trying to overcomplicate the platform, but then we realized that a simple bookmarklet was not only easier to implement, but also more accessible to learners because the bookmarklet was always visible on the page via the bookmarks bar, but similarly unintrusive. Um, and as far as future work, user testing revealed a couple of important affordances that we could still implement. First is differential color coding depending on the role of the directive within the overall application hierarchy. So, for example, ng scope and ng app means a different thing with regard to the application's architecture than ng repeat or a simple ng include partial. And similarly, being able to display information about the directive used when you mouse over a selected element, perhaps in a tooltip somewhere in the bottom part of the screen, was a feature that a lot of the users who tested this implementation said that they would find useful. Overall, we've sort of crystallized a lot of the affordances that we might want to implement into the app based off of the idea of making the DOM more accessible to learners who aren't yet familiar with how things like Angular and React work. And we're really excited about where we can take this in the future.